If the shape of the earth didn't matter, why they made it a ball?
Exactly.
If it didn't matter, why was it changed from one thing to another thing? Why was Yahweh Shai changed from black to white? Why was the angels changed from tall black men with afros to little babies with diapers? It just made no sense, man.
I'll explain.
You get me?
They changed the shape of the earth because you see, under the globe Earth means you gotta believe that the earth is spinning around the sun, and that there are other planets and other life forms. And with all these lies, there is no belief of a God, because it goes back to the Big Bang. And all it is to remove the belief of a creator in the Most High from our minds. To have us thinking that there are other aliens, and the universe is vast, and we have no control, rather than understanding that this earth was created for us, and there is a purpose. There is a purpose for us in this earth, rather than us just being walking life forms on some random planet. That is not the case. He created this planet specifically for us. As the book of 2nd Esdras reads, the world, for we know that he made the world for our sakes.
He did. I mean, of course, the world is for us, the Israelites. Now, I was just thinking about that too. When you said planet comes from the word plane, which means it basically just means it's flat. Like you can't have a plane and what is it? Plane only just means it's flat, man.
The flat earth resonates with me because it's something that it's very easy to accept, if you will, because all you have to do is accept it. You don't have to do anything. You don't have to do any experiments. You don't have to figure out any equations. You don't have to suspend your belief, your belief in your own senses. You understand? So that's why I resonate towards flat earth. On the flat earth side, you sort of mean something. Your life has a meaning to it. You count, and there is something about that, as far as I'm concerned, that really resonates with me. So because of that, I have just made a conscious decision. It's not based on any evidence or anything, but I've decided to be flat earth and go ahead and declare myself as flat earth.
Pop off whenever you're ready.
My name is Flat Out Hero. I'm part of the YouTube community that is trying to make a movement to present Flat Earth to the world, to try to spread truth about it. And basically, the entirety of my movement is me. My main purpose in this is not to tell you that the Earth is flat or to even try to get you to think that. My purpose is strictly to show you that there is a lot wrong with the ball Earth theory.
Lone wolf on this flat plane, right?
I want you guys to think that I'm outnumbered, and I want you guys to think that I'm going to be totally dumpster fired. I'm straight up with you right now. That's what I want.
All right, let's get it on. Conspiracy Catz.
The only shape that will allow us to see Polaris above the North Pole at the same angle as the latitude has to be a sphere. And for us to repeat that with the southern celestial pole, right, then we're not just half a sphere, we're a complete sphere. If we had any other geometric shape, that line would not be constantly at 90 degrees towards the center of the Earth, and it would be physically impossible for it to be any other shape, unless you can think of a shape that allows us to see Polaris at the same latitude, the same angle as our latitude, but those shapes don't exist. So what I'm wondering is, what is the flat Earth explanation for being able to see the celestial poles at the same angle in the sky as our latitudes?
Kind of overloading me with some shit. I can respond to like little bits and pieces, but you're throwing me way off with all that shit. Like, why is that straight line, that little short 30 line, why is it straight if it's a latitude, or like why isn't it curved?
The line that's straight is what we call a tangent line, and a tangent line is at 90 degrees to the center of the shape. Okay. Now, with a sphere, if we draw a tangent anywhere on the shape, it's always at 90 degrees. A sphere or a circle, sorry, is the only geometric shape that we can ever get a tangent line at 90 degrees to the center.
You're wrong. You're not. Your premise is way off. Like, what you're saying is it can only be done on a sphere because of what? Like, what have you tried with a computer program that simulates a flat and showing what the distance is? Or because if you simulate a sphere, you're not going to be able to make that work. What you're really like trying to say is that it's for sure only going to be able to be done on a sphere. But I got to ask you, like, what tells you that? How are you coming to that conclusion? Do you have any sources you can cite that say that that's the only way it can happen? Or is that just something that you're saying?
There is nobody out there that doesn't understand what a tangent line is on a circle that would disagree with what I'm saying. It's established fact. You know, it's like you asking me now to prove that planes have wings. I can't go and get a plane now and show, but we all know planes have wings and bananas yellow. All right.
Yeah, I can show you a million videos and pictures and fucking how to build a plane. Like, you know, I can prove that it has wings. Like you're just not. I'm asking for a source, bro. Like I know you got an opinion and I respect your opinion. I'm not even saying it's a bad opinion, bro. I just want to know where's the source, because just because you're saying it isn't really impressing me. I want to know who else has said that.
Any maths book you will ever put your hands on will have that in there.
Great. What's the name of
any
one?
maths book, anything to do with geometry.
Where's the one you got it from, dude?
I gotta admit, asking for a source on something as simple like, I don't know, a basic mathematical theorem that we all learned in grade school probably isn't really advantageous.
Should be simple as fuck.
Position. It is.
Why? It should be the most easy thing to find.
Anthony, if a triangle has the sides 1, 1, and 1, do you know what the angles of the triangle are?
Which kind of triangle are you on about? Are you on about like a right angle triangle?
The triangle has sides 1, 1, and 1. Do you know what the angles are?
The angles would be, well, it would be an equilateral triangle, wouldn't it?
Right. So what are the angles? Now I'm going to ask this again. If you have a triangle with sides of 1, 1, and 1, what are the angles?
I'm gonna pull up a triangle calculator.
Let's do this again. Anthony, a triangle has sides 1, 1, and 1. What are the angles? Is somebody recording this? Because this is just priceless.
Well, the one I'm using it's not giving me any when I do it. So either this calculator is wrong or you're wrong.
We have a triangle with sides of 1, 1, and what are the angles?
Yeah, so that's an equilateral triangle, right?
Right. So what are the angles?
Does that work on a right angle triangle?
The sides are 1, 1, and 1. What are the angles?
When is that ever used in astronomical calculations for measuring trig?
I'm not going to tell you that until you answer my question. The triangle has sides.
It's not relevant. We use right angle triangles to calculate the distance things, correct?
We don't even need to use right angle triangles.
What you're describing only works with an equilateral.
Anthony, the fact that you can't answer these simple math questions, crap you, is ridiculous.
Why can't you just apply it to right angle triangles?
Fine, 3, 4, 5. That's a right angle.
How do you know it's a right angle triangle?
Because 3, 4, 5 triangles are right angle.
So
because it physically is. There's no other. There's no other triangle it can be.
All right. Well, I don't know that's true, so I want to test it. How do I test it?
Okay. So for the other people playing at home, maybe you can answer these questions while Riley's trying. You have a triangle with sides 1, 1, and 1. What are the angles?
60, 60, 60.
60, 60, and 60. I heard somebody whisper. You're correct. Now, if you have a triangle with sides 2, 2, and 2, what are the angles?
Let's give Anthony a chance to respond.
Well, this is irrelevant. I've already stated my position.
No, it's not. Your inability to do math is totally
triangles. We don't use equilateral triangles to calculate the distances and stuff. We use
Well,
right-angle triangles.
I think the issue here, Sleeping Warrior Anthony, is that you don't know how to do any of this math.
Lewis's point
what?
was that if Lewis's
No,
point
my
was that
point
if,
was that you do not know how to do this math. That was my point. That
Well, that-
you,
what
Anthony
he-
Riley,
what's been
do not
demonstrated-
know how to do
Lewis.
this math.
now how does that apply to astronomical features in the sky?
It doesn't.
Right.
It applies to you not having a clue what you're talking about and being extremely confident when you talk, regardless.
Well, that doesn't change the fact that you don't know any of the distances, or in this case, the ISS, the distance to the ISS.
And that doesn't change the fact that you don't know what you're talking about ever.
Crepuscular rays is fascinating. Oh, by the way, there's various names for it. Sun rays, sunbeams, cloud breaks, fingers of God, God rays, Jesus rays, Jacob's ladder. So there's a lot of different names for it, but we all know it as those great, beautiful beams that shine through the clouds. So let's just call them sun rays for simplicity. So then the modern scientific explanation is that sunbeams are parallel shafts of light that are coming from the sun, okay? Because the sun is so big, and like that big light behind me, okay? That's a huge studio light behind me, and just see that light, and then consider a marble next to that light, okay? So the earth is so small, the sun is so big that the shafts of light from the sun hits the earth, and the shafts of light from the sun are massive, millions of times bigger than the earth. So therefore, the beams should come down as horizontal, okay? They should not spread out. They should come down as horizontal. And scientifically, they're correct, all right? But that is not what we experience.
The idea that the sun's light is going to bend like this when it goes through the atmosphere, right? So this is the top of the atmosphere, let's say, and the sun, let's say, is right here. This is the sun. And so the idea that the sun's light is going to bend this way, whereas the moon's light is going to bend that, like that, right? So it means that if we follow the line as if it's a straight line, we're always going to misidentify the origin point of the sun and moon in terms of where they are outside of the atmosphere. That has applications for the oblate spheroid Earth, right?
The sun getting smaller as it moves away is because we're on a flat plane.
The curvature up here is going to be slightly different than the curvature on the southern hemisphere if it's an oblate spheroid. As they say, NASA, Neil deGrasse Tyson, physics, astronomer, everybody in the world, right? That's what they're trying to pretend, that we live on an oblate spheroid. So then the curvature in the southern hemisphere is going to be slightly different, right, than the curvature in the northern hemisphere. As a result, the sun, it wouldn't triangulate the same way, right? And so even in terms of time zones, like it introduces a lot of problems, because if this is your triangle with a curved bottom in the northern hemisphere, then in the southern hemisphere, that curvature is going to be 3% different, right? And it's going to be a little bit less curved because it's an oblate. So all of a sudden, you're not meeting at one point. All of a sudden, you have divergent lines. So then you need two suns to create those two people that are looking up and both seeing the sun at the same time, one seeing it rising, one seeing it setting, right? These are things that I keep kind of bringing up. And this is the thing, I thought, well, maybe people just aren't understanding because the globelings are silly. But I'm realizing, or maybe I'm not explaining it well enough. So I need to revisit it and figure out how to explain it differently so that people, the globelings, can understand what I'm saying better, and then they'll understand that that actually disproves their model.
The light source is close. It is not, the sun is not 93 million miles away. The sun is not 240,000 miles away. They would have to be close to the clouds. And we've all seen photographs of clouds immersed, the sun and the moon immersed in clouds. The clouds in the front and the clouds in the back. I've heard that that's a distortion. That's not how distortions work. It is not a distortion. And if the sun and moon are within the clouds, that means that they are very close. Clouds tend to be 5 to 7 miles high. Okay, so that's 28 to 36,000 miles. All right, that means the sun and the moon is roughly 5 to 7 miles high. And I know that trips a lot of people out when they hear that. And that's only because that's what we're taught. All right, try to get past that. Look at the evidence. They can't be 93 million miles away and create those beautiful beams. That is not possible. So based on the evidence, the sun and the moon, or whatever those things are up there, because there's so much we don't know. The sun and the moon is 5 to 7 miles high. They're close to the clouds, and in many cases, right in the midst of the clouds.
Have we ever figured out if we ever found a flat earther that had any kind of PhD in any kind of like physics or anything like that? Is there even one? Just one?
Brother Sanchez.
The reason why the earth is not a globe is because there's not enough substantial evidence to prove that it's a globe. Everything that would support the globe is theoretical, it's not factual. Your eyes are curved, but not the horizon. So your eyes will bend things, and you still don't know how your eyes work. You think it's curvature you're seeing. So I'm gonna show you right now, right? That it's all a mirage, and what you're seeing is that the further away things go, the more of the bottom you lose. Things vanish on a horizon from the bottom up, just like we see here, just like with the setting sun, just like the picture Rhetoric showed us, where he showed you lost a little bit of the bottom of the building. That's because you're on a flat plane, and as things go far away from you, you lose more of the bottom of that thing.
How about you show me objects disappearing over the horizon of a flat surface with the camera actually leveled with the surface of the table and not below it? This observation clearly does not match reality, because in reality, we don't film ships disappearing over the horizon from underwater.
Let me explain mathematics to you, sir, please. Just 1 minute if I can.
Sure thing.
The reason the camera is below the table is to compensate for the length of the table as opposed to the length of the actual beach horizon. So in order for us to see the quarter, the star vanish, in order for us to see the quarter vanish on the table, how we see the sun vanish on the horizon at the beach, we will have to put the camera lower to compensate for the length of the ocean. This is simple mathematics.
You are clearly a very smart individual. You know mathematics like the back of your hand.
If your research showed you that the sun does not change size, hey man, more power to you. It's just that my research shows me contrary to that. My question for you would be humbly, where am I going wrong with my research?
In order for this observation to comport with reality, not only would the camera have to be above the waterline, but the angular size of the sun would also have to remain constant, which means that as that coin is moving further and further back, it has to remain the same size in the frame. In this video that you yourself linked to, you can see that that coin is changing in angular size. When we do observations of the angular size of the sun in reality, we see that it does not change.
We can get into the solar filter and say, well, the sun shrink or it doesn't shrink as it goes away, but it's taking its heat also, and that's giving us an indication that it's a local light source. And it is indeed shrinking on the horizon, because the more it shrinks, the colder it gets.
Or it could be that the light is getting blocked by the horizon because a sphere can only be illuminated halfway at a time.
The word local is related to the word location. Things that are local are they reveal their location.
So we've seen the same face of the moon for centuries, even while for the last century we have had rockets, earthquakes, planes constantly taking off, landing, volcanoes going off, every fucking force on the earth you could possibly imagine, bomb after missile after explosion. But none of this ever magically affects Earth's rotation and gravity. Yet we overpower gravity every fucking day, people. This overpowers gravity easily. This little magnet, look at that. But a fucking volcano going off on a weightless ball spinning in space, the force doesn't affect it at all?
And one of the observations we have on the globe is boats going over the horizon and being lost behind the horizon. All right. So if you were to see a boat going over the horizon and being lost behind the horizon, right? If you were to see a boat being lost behind the horizon, what would your reaction be?
Is this using optics or not?